We've been asked many times to explain what is band pattern. When you use Cadfil for filament winding programs, you often come to a screen where you have to select a band pattern. So in this little video, we're going to explain a little bit about band pattern. Okay, so firstly, we're going to sort of create some simple program. So I'm just going to find a mandrel that I prepared earlier, which is this one. So we've got a cylinder with some standard domes on it. Okay, don't need to save that. Cancel. Okay, so now I'm going to use a vessel with end caps to create a simple winding program. Okay, so in this example I'm going to use custom mandrel, the one we've just looked at. So all the geometry envelope is defined from the custom mandrel. So winding, well, first set some materials. New material, yes, it's coming into the database. So use recipe. So I've got some recipes. I'm going to just select this one, 4 rovings, 20 millimeters bandwidth. Okay. So 20 millimeters bandwidth. Those are the materials. It's a Torre T700. Wind angle for this layer, 20 degrees, fairly low helical handle. And then I'm going to calculate. So it says, do I want to save this? And yes, I'm going to give it the name. It's already there actually. Test. Okay, bandwidth thickness. Okay. So this is the band pattern table. So a number of things here, a number of cycles. That's a number of circuits to make a complete winding layer to fully cover the mandrel. We've got a number of options here and we've got a number of patterns. So first I'm going to just pick this one, band pattern number 8, option 3 in this case. So I'll click OK, and this is the winding draw bands. Yeah, so that's what it looks like, winding. So I'm going to actually look on this end here. So I'm going to look at the X plus end, and that's the first circuit. We see about 20 degree winding. Draw bands, no. Draw the next band, yes. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, band pattern of 8. Draw next band 9, and it's next to the first one. So we're now going to fill in all the gaps. So that is in essence what a band pattern of 8 means. We get the coverage starting from 8 places and then it starts to fill in. Okay, let's just complete that now. So that's a band pattern of 8. So if we exit from that, we're going back, vessel with end caps, open, test, those are our parameters there. I'm going to calculate again now. And so band pattern of 8, I'm going to pick a band pattern of 9. Bands, take the end view. No. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. That's really an explanation of what band pattern number actually is. But we can go a little bit deeper than that if we want to. So, if we go back to the band pattern table, so I think caps, open, test, calculate, save, okay. Table here, if I go into the help, and it's hopefully put the help on a different screen to the one we're recording. So let's bring it back. Okay. In here it talks band pattern of 3, so you can see the pattern building in 3 segments. But 1, 2, 3, 4, 5, 6. Just diagrammatically like what we looked at a short while ago. But effectively, we could get the case where instead of the bands advancing in the direction of rotation, the next band is coming in the opposite direction. So we'd just basically call that either a lagging or a leading sort of pattern. And that's really the only difference. So sometimes you can get a band pattern of 3, for example, but it gives you 2 choices because both work. So what are the choices? Well, let's explain this a little bit. So when it generated this winding program, the basic winding program, a circuit of the mandrel going along the mandrel, around the dome, coming back, completing the first dome. It's done 1 rotation of the mandrel and 49.14 degrees of mandrel rotation. So in total that's 409 degrees of rotation. However, if we actually wind 409 degrees of rotation and repeat it 89 times, we'll find the bands don't come evenly distributed around the mandrel, making a nice pattern and a complete layer with no big holes anywhere. So to actually get it to fill the mandrel correctly, we need to adjust this rotation to make it effectively a non-cancelling fraction, so it uniformly fills the mandrel. So if we look at our panel of 8, we actually need 404 degrees of rotation, not 409. So we need to lose 4.6 degrees of rotation throughout the entire program. So the mandrel is going to rotate a little bit less on every circuit. Now, because of the way it works, we effectively progressively lose that rotation in the entire program. So effectively, every degree becomes 0.98 degrees of mandrel rotation. So this is what we call the progression factor. So ideally, we want this to be 1 or as close to 1 as possible, which is why these patterns are listed in that manner. So this shows how close they are to 1. So that's the best one, that's the worst one. So in general, you're always picking someone with a progression close to 1, and it's always going to be at the top of the table. So that, in essence, is band pattern. Thank you for listening.